the column of differences. So let's do it on our calculator, and let's do a real example. And maybe I should write some generic instructions here in some different color. If I had a different color. Let's see. So in the calculator, put the differences into L1, and then you're going to just say stat test t-test. Data or stats? Data. Then it will say what list? You're going to say L1. What is the frequency? You will say 1, because every number is occurring one time. And then it's just going to spit out for you. Calculator will give the T0 and the p-value as usual. If it's a two-sided test, you can also do a confidence interval on this. And the same way, you would say stat test t interval. Data or stats? Data. What list? L1. What's the frequency? 1. Finished. Let's do a real problem, okay? And this problem is on... And everything that I just said can be found on page 14 and 15. Let's go to page 16 and do the example. Two creams are available by prescription for treating moderate skin burns. A study to compare the effectiveness of the two creams is conducted using 15 randomly selected patients, n equals 15, with moderate burns on their arms. Two spots of the same size and degree of burn are marked on each patient's arm. One of the two creams is selected at random and applied to the first spot, while the is treated with the other cream. The number of days until the burn has healed is recorded for each spot. Is there a difference in the healing time for these two creams? That's the first part. And then the second part says construct a 95% CI for the difference in healing time. Use this to reach the same conclusion as in part A. Okay, so this is definitely matched pairs because it's the same subject with the two arms, one cream on one arm and one cream on the other arm. So the differences that are going to be observed is definitely due to the creams because it's the same subject that is going in. So it's definitely matched pairs. So matched pairs. And this is a two-sided test because they just want to see, is there a difference or not? They're not saying, is cream 1 better than cream 2? Or is cream 1 less effective than cream 2? That's not what they're saying. They're saying, is cream 1 the same as cream 2 or not? So this would be a two-sided test. So I go ahead and I write that here. H0, mu D equals 0 versus HA, mu D not equal to 0. Where mu D is just mu 1 minus mu 2. Two-sided, and therefore I will create a T distribution here. There's two alphas here. There's alpha split here, alpha over 2 here and alpha over 2 here. So the total alpha was 0.05, so alpha over 2 is 0.025 in each tail. Just as usual, nothing is different here now. Degrees of freedom is 14 because it's n minus 1. I go and I find all the differences. 16 minus 14, 2 minus 4, blah, 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 all the way to the end. Then you take this column and you create a L1 column of these differences. So just to show you that it will match your calculator, what I have done is do stat calc one variable statistics on L1, and I found out that the mean is minus 0.53 and the standard deviation was 2.26, and then I did it by hand just to show you that it works out. So if you were to put these differences into a column, would you like to do it right now? Do it so that it's one thing that you already know how to do. Put these differences into some L1 and then go do stat calc one variable statistics. I'm here, see? Stat calc one variable statistics on L1. And the calculator will spit out the mean and the standard deviation. Once it does that, I can demonstrate to you this t-test. So I use this minus 0.53 number for d bar. So here I am. Instead of writing x bar minus mu naught over s over rad n, I'm writing d bar minus mu d over sd over rad n. So minus 0.53 minus this mean. This comes from here. This came from here. Over s. This is the s of the differences over rad n. And that number turned out to be minus 0.9. That's my test statistic. I also need critical values, so I will go to my t-table with 14 degrees of freedom. Let me do that right now. T-table with 14 degrees of freedom and 2.5 in one tail. So let's go to the 0.25 column. And 14 degrees of freedom, I see 2.145 right here. That's my critical value. That's where I'm getting this number. And its negation, which is minus 2.145. And then I go and I drop the test statistic and I see that it falls here, which is not in the critical region. So do not reject H naught. That means there's no evidence that there's a difference. I'm not rejecting that mu equals 0. The difference equals 0. Conclusion, there is no evidence that there is a difference in creams. The test is not significant. The test is not statistically significant. Are you with me? And then the second part says, this is a two-sided test, so why not go create a confidence interval? Which is what I'm going to do. Remember the old formula? It used to be this, x bar plus or minus, x bar n plus or minus t alpha over 2 s over rad n. That used to be the formula that I used to know. So now, it's not x bar, it's d bar. Plus or minus t alpha over 2 s over rad n. Nothing has changed. You follow, right? It's just a regular t-test. So here's the difference, the mean of the differences that I found on my calculator. That number is sitting right here. Plus or minus t alpha over 2. That's just this number. S, standard deviation, over rad n. and I create a confidence interval, and that interval turns out to be minus 1.78, comma 0.72. My job is to go drop the 0 and see where the 0 falls. So here's the confi interval, minus 1.78 and 0.72, and turns out that this 0 right here from the mean difference from the null hypothesis, that 0 falls here. So do not reject H0 is my conclusion. As usual, when what you see in the null hypothesis falls in the confidence interval, your conclusion is do not reject H0, which is what I'm saying. Do not reject H0. That's a matched pairs design. Is it completely clear? Any question? So on the next page, by the way, before and after studies are also matched pairs. So for example, if you're undergoing chemo, you can take observations before chemo and after chemo. That would also be a matched pair design. So before treatment and after treatment is definitely matched pairs. Twin studies as well as before and after studies are matched pair designs. Here's another example. The toughest part of this whole thing is to just create the null hypothesis and the alternate hypothesis. After that, you're home free because your calculator will do all the work for you. Let's read the question. Although OSHA is not very popular with management because it is too expensive to implement, some sources claim that it has in reducing industrial accidents. The following data was collected on lost time both before and after OSHA came into effect. The figures given are mean man hours lost per month over a 1 year period at 6 different industrial plants. So n equals 6. They gave me before and after observations. I am going to go take the difference between before and after, and here is my column of differences. The hardest part is this. After that, it's all same old, same old. So H0, I don't think I see a H0. It's here. Mu before minus mu after equals 0 versus mu before minus mu after greater than 0. Why am I doing a right-sided test here? They said go see if OSHA has been effective in reducing industrial accidents. So I want to see if the number of accidents before is greater than the number of accidents after. Do you agree with that? Mm-hmm. Therefore, I want to see if mu before is greater than mu after. And once I bring this mu after to the left-hand side, it becomes this statement right here. Mu before minus mu after greater than 0. Which is why this is mu d greater than 0. So this will be a right-sided test. That's the hardest part of this process, and it's not even that hard. It's just reading the question. After that, you just stick it in your calculator. So then, when I did stat calc 1 variable statistics on L1 after putting these differences in L1, it gave me that the mean was 4 and the standard deviation was 3.2249. After that,